Hello friends, myself Rajendra Mahajan presenting my video on first shifting theorem of Laplace transform revised series. In this video I will first define what is by first shifting theorem and then examples on it. The statement of this theorem is like this. If Laplace of f of t is equal to f bar of s, given or we can obtain it. Statement of the first shifting theorem. If Laplace of f of t is equal to f bar of s, given or we can obtain it, then Laplace transform of that f of t multiplied by e raised to at plus or minus. If it is plus at, then its Laplace is f bar of s minus a, and if it is minus at, then its Laplace is Laplace of e raised to minus at into f of t is f bar of s plus a. Therefore, remember this shortcut technique. If it is plus at, replace by s minus a, and if it is minus at, replace s by s plus a. This is the statement of that first shifting theorem. After knowing first shifting theorem, we try to see how we can apply it, how we can use it to find the Laplace transform of the given function by some simple example. I am discussing total 6 examples of first shifting theorem like this. First one, find the Laplace transform of the following. The first one, t raised to 5 into e raised to 4t. Second, e raised to minus 3t into t raised to 3 by 2. T raised to 3 by 2. Third, e raised to kt into sine bt. E raised to kt into sine bt. Fourth one, e raised to minus 2t into cos cube t. Fifth, sin h4t into e raised to minus t. And the last one is cos 2t into cos h3t. Except the last, in every problem that f of t is multiplied by some e raised to at plus or minus. It indicates that it is a problem of first shifting theorem. Therefore, we try to solve one by one. The first one, t raised to 5 into e raised to 4t. Here that t raised to 5 is multiplied by e raised to 4t, means it is a first shifting problem. We know the Laplace transform of t raised to 5 or t raised to n, generalized formula, as n factorial divided by s raised to n plus 1 if n is positive integer. Here the value of n is 5. 5 is positive integer. And therefore, using this standard result, we try to find out Laplace of t raised to 5 as a 5 factorial divided by s raised to 5 plus 1 means it is 6. And we call this is f bar of s. F bar of s means the Laplace transform of that function. Then, by first shifting theorem, FST means first shifting theorem, we get the Laplace of t raised to 5 into e raised to 4t. It is plus 80. Therefore, replace s by s minus a. A is here 4. Therefore, replacing s by s minus 4 in that previous result, therefore it becomes 5 factorial divided by s minus 4 whole raised to 6, a required answer or required Laplace transform. Very simple. Then second, e raised to minus 3t into t raised to 3 by 2. Before that, watch the video up to end for better understanding, clear understanding. Once again, we know the result, standard result, Laplace of t raised to n when it is not positive integer, as gamma n plus 1 divided by s raised to n plus 1. If it is not positive integer, n is not positive integer. And another result from gamma function, gamma n plus 1 as n gamma n, and the value of gamma 1 by 2 as square root of pi. All these required results. Then we find out Laplace of t raised to 3 by 2 by the above result, as gamma 3 by 2 plus 1 divided by s raised to 3 by 2 plus 1. Nothing but gamma n plus 1 is n gamma n, therefore it is 3 by 2 into gamma 3 by 2 and whole divided by s raised to 5 by 2. 3 by 2 plus 1 we get 5 by 2. Next step, 3 by 2 we keep as it is, and that gamma 3 by 2 we write down as 1 by 2 plus 1, gamma 1 by 2 plus 1. And again applying that result, gamma n plus 1 is n gamma n, means it is 1 by 2 into gamma 1 by 2 and whole divided by s raised to 5 by 2. It is 3 by 4, gamma 1 by 2 is root pi and divided by s raised to 5 by 2, and we call this is f bar of s. Say, then by first shifting theorem we get Laplace of e raised to minus 3t into t raised to 3 by 2 as f bar of, replacing s by s plus 3 in the above result, and therefore we get value as 3 by 4 square root of pi divided by s is replaced by s plus 3 and whole raised to 5 by 2 as the answer or the value of that Laplace transform. Then we go for the third example, e raised to kt into sine of bt. Therefore, we consider f of t as sine bt. We know this result for Laplace of sine bt as b upon s square plus b square, a standard result of Laplace of sine at as a upon s square plus a square, and we call this as f bar of sc. Then as it is multiplied by e raised to kt term, it becomes a problem of first shifting theorem, and therefore by first shifting theorem we get Laplace transform of e raised to kt multiplied by sine bt as replacing s by s minus k. It is f bar of s minus k, and that is equals to, in the above result we replace s everywhere by s minus k, therefore it is b upon s minus k whole square plus b square, a required answer. Then fourth, e raised to minus 2t into cos cube t. Therefore we consider it function as cos cube t, whose Laplace is not a standard result. Therefore we have to rewrite that cos cube t by trigonometric result as 1 by 4 3 cos theta, means cos t plus cos of 3t. That is first step. Then taking Laplace on both sides, Laplace of left hand side and is equals to Laplace of right hand side. Therefore Laplace of cos cube t is equals to 1 by 4, means it becomes 3 by 4 first term, and Laplace of cos t means multiplying by 1 by 4 inside the bracket. We get second 1 by 4 Laplace of cos 3t. It is 3 by 4 as it is. Laplace of cos t, standard result, s upon s square plus 1 square plus 1 by 4 s upon s square plus 3 square, and we call this as f bar of s. Say then by first shifting theorem we get the Laplace of e raised to minus 2t into cos cube t as f bar of replacing s by s plus a is here 2, and therefore in the above result we replace s by s plus 2 throughout. We have 3 by 4 into s plus 2 whole divided by s plus 2 whole square plus 1 first term, plus second term 1 by 4 as it is, no change, plus 1 by 4 multiplied by s replaced by s plus 2, we get s plus 2 divided by s plus 2 whole square plus 3 square means 9. A required result, a required answer. Then fifth, sin h 4t, it is multiplied by e raised to minus t. As it is multiplied by e raised to minus t, it becomes the problem of first shifting theorem. Therefore, first of all we find Laplace of sin hyperbolic of 4t, and we know this result, Laplace of sin h at as a upon s square minus a square for the condition s greater than a. Using this result, we write down the Laplace of sin h 4t as a is here 4 divided by s square minus 4 square and condition s greater than 4, and we call this as f bar of s. See, then by first shifting theorem we get Laplace transform of sin h bt, sin h 4t multiplied by e raised to minus t as f bar of s is replaced by s plus a is here 1, coefficient of t is 1, and therefore in the above result we replace s by s plus 1, we get 4 upon s plus 1 whole square minus 4 square as a required answer for the condition s greater than a is here 4. Very simple problems. And the last one, cos 2t into cos h 3t. Here there is no any term of e raised to plus at or minus at, but we know this standard trigonometric result for hyperbolic function. Cos ht we can rewrite as e raised to t plus e raised to minus t upon 2. Therefore, that cos 2t into cos h 3t or cos h 3t becomes e raised to 3t plus e raised to minus 3t divided by 2. And therefore, Laplace of cos 2t into cos h 3t we replace by this new term, and therefore it becomes Laplace of cos 2t into e raised to 3t plus e raised to minus 3t by 2. Then splitting it 1 by 2 we take outside, and here function is f of t as cos 2t whose Laplace is known, or we can obtain it as s upon s square plus a square. A is here 2 means 2 square. That is s upon s square plus 4 as f bar of sc. Then by first shifting theorem, we get Laplace of cos 2t into cos h3t, cos 2t into cos h3t. Cos h3t means e raised to t plus e raised to minus t upon 2 as it is 3t plus e raised to minus 3t. 1 by 2 outside. It is Laplace of first one is f. In f bar of s, s is replaced by e raised to s is replaced by s minus 3, and in second result it is replaced by s plus 3. Therefore we get 1 by 2 as it is, no change. S upon s square plus 2 square, in that we replace it by s minus 3. We get s minus 3 divided by s minus 3 whole square plus 4, and plus in second s replaced by s plus 3 divided by s plus 3 whole square plus 2 square means 4. A required Laplace transform. Like this very simple problem on first shifting theorem. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.